Hello, this is a quick ad hoc screencast to go over frequency mapping in PERSIST. We're going to use an example that shows a seizure evolving from faster to slower. Very easy to see what's happening in the waveforms, and so that's nice to illustrate what the maps are showing as well. So I'm just going to open up the PERSIST database, open up this recording, and we will see the waveforms and trends. I am Michael Guess, VP of Research and Clinical Applications for PERSIST Development Corporation. We have our artifact reduction on. We're looking at trends and waveforms. And here we have some seizure probability, rhythmicity spectrogram deflection showing up at the onset of a seizure. Here, if we page into this, we can see some beginnings of that in the channels. And then there we go. There's the seizure. And it's evolving from faster to slower. And let's say we wanted to use this particular example to look at the frequency mapping in PERSIST. So to do that, let's go ahead and select the Tools menu and launch Insight 2. And that will launch, the program is still PERSIST 14, and these tools are in PERSIST 13 as well, of course, to do the frequency mapping. So let's go ahead and move forward to a point in the recording. And typically, we're reviewing, we may be reviewing in any particular type of montage. And so in Insight 2, again, we're looking at PERSIST 14, but this is skinning it with a different user interface that has some different tools available, specifically for doing more detailed analysis of the EEG. So we can also navigate using our comment list. And of course, we can go down here. There are comment lines being displayed within this trend bar at the very bottom. However you do it, we'll get to the point of interest. And I'm going to go ahead and close that box again just to move it off screen a bit. Now, this is a bipolar montage. We don't want to map it a bipolar montage, typically, in almost all cases. And the reason for that is, imagine a topographic map, you being used for hiking through the mountains. If each point on the map was referenced to some other point on the mountain, it would be very difficult to make sense of it. And so topographic maps are usually referenced to height above sea level, and they draw those elevation lines. Same thing for EEG. For mapping, it's nice to have a single reference. In this case, you could use a single point reference, or you could use a Laplacian, very common used for mapping, or you could use, in this case, let's just pick an average reference. And the selection of a reference is similar to what you'd pick for EEG review. You don't want an active reference or a contaminated reference that will alter the waveforms in a way that's not helpful. So all that being said, we have our referential montage applying the FFT, fast Fourier transform, delta, theta, alpha, beta map. Very easy, just pick it from that drop-down list, and there it is. Now, if it doesn't display correctly, when I move the mouse over the borders of these windows, I can resize things, and I can drag them around the screen to make them larger or smaller, or to reposition them. Now, there's 4 maps over here, and you can see there's 4 bins marked in this FFT representation for each channel to the right. And so at the very bottom, we have beta, alpha, theta, delta. So there's our D tab from top to bottom. And right now, it's doing the current page. And so as I page into this, you'll see that it lights up at the beta, then it moves down to alpha, and as the seizure evolves, we'll see it lighting up in the theta band, and then at the offset of the seizure, we'll see more activity showing up in the delta band. And if we go far enough and away from enough of this slow stuff here, we may see some hints of post-ictal slowing showing up, but again, in the trend, it's actually a little bit easier to see, and certainly in the waveforms you can pick that out. So that's not something that you can't see from the waveforms themselves. So let's go back to this. Now this is doing a full page. Let's change it a little bit so we can look at this evolution of the seizure in a little more detail. I'm going to right-click on this graph here and go to Properties. Now, by default, this one's set up to use data ranges, so I just click the Data Range tab to use the EEG page, but we're going to change that to use a range that I'm going to place onto the EEG itself. And just a quick look here, we're doing analysis type is binned analysis, and we have our delta, theta, alpha, beta bands here, loaded from a file. We're going to go through how to create this manually next after doing this with a pre-configured one. First thing I'd like to do is I'd like to have a range mark. Now you can mark multiple ranges for measurement in the EEG, and you can average them together. But in this case, I want to step through the evolution of a seizure. So I'm just going to pop a range onto the EEG here, and I want it to follow me, so I don't want to fix the position of those cursors. I want them to go where I go. So I'm going to remove this fixed position of new cursors, right-click here, put the mouse to where I want it to start, right-click, insert range, and then we get this ability to mark a range. I'm going to do a couple of seconds. You can modify the FFT measurement parameters to change the number of points per window, which is essentially saying, oh, how many samples am I going to use to calculate the amplitude by frequency? Now, the fewer the points you use, the shorter that window. You have a trade-off between time and frequency resolution. So as you increase the time resolution, you lose frequency resolution. And that's fine. You can pick something that's optimal for that. Or you can increase the sampling rate. That increases the points as well. But we'll set this to 2 seconds with the default at typical scalp sampling ranges. If you do, start getting less than a couple of seconds or 1 second, that window will disappear. And that's the reason is you don't have enough points to calculate the FFT. And so just make it a little bit bigger and it'll work fine. All right, so we have this. And now I want to tell it to use this range. So we'll right-click on this, go to Properties, and I've got all these tabs at the top. The data range one is the one we want to select. I'm going to pick ranges. And this is a visible range. You can pick selected ranges, which gets into finer details of selecting particular ranges to average. We're not going to be doing that in this case, or all. Well, I've only set one, and all will cover it. And you can see the map has changed here as well. So let's go ahead and begin stepping into the onset of the seizure, and we'll see the maps begin to change. So now that we're looking at this range here, we can see it lighting up in the right front for the beta range, which makes sense. That agrees with what we're seeing in the waveforms. And then as we step forward through this, I just want a full page, actually, and we can see it lighting up in the alpha band here. So, important note, if you click to the left or right of this position in the thumb bar here, it's going to go full page. Now at the end of this scroll bar, you have these bunch of arrows that can jump different amounts, but this single arrow here is just going to nudge it 1 second at a time. So if I want to go through 1 second at a time, just click that arrow there, or the one on the left side, it'll take us back, and then we'll go ahead and step through the evolution of the seizure. So you can see it lighting up in the beta and the alpha bands here, right in front. And as we go further, we'll begin to see the theta light up as it evolves from faster to slower. Now note the artifact reduction is on. In most cases, you're going to have the artifact reduction applied. Not a lot of muscle or other contamination, physiological artifact contamination in this particular segment of EEG, but that's certainly going to skew things if you don't take measures to reduce that. And the spatial filtering in this is the same spatial filtering that's used in the persist interface that we started with. So the difference is there's an AR button in that one. In this interface, you can hit apply, and like that one, you can selectively remove muscle, eye blink, lateral eye movement, or you can leave these other ones in. Well, for this application, we're going to reduce all the contribution of that. Let's continue going through the seizure. And now we see it lighting up the theta map as the alpha begins to show less of a contribution there in that frequency range. And then we get towards the offset of the seizure. And that's that. And, then you see these other components contributing to the delta map. And that's the important thing is you look at the EEG and you can make sense of what you're measuring and what you're seeing in the map. Because maps without the EEG, it's sort of like closing your eyes and walking on a mountain with a topographic map. It's good to have your eyes open and see the details so you know where you're setting your foot. In that case, we paged past some of that artifact and even some of the post-ictal slowing showing up here that you can see clearly in the waveform data. But earlier, it looked like something different because there were other things contributing to the map that we can see here. So, having said all that, let's go back to the beginning of this. And let's see how this is constructed. So if this is enough information for you on how to show these maps and how to do the range, you can bail out here. I'm going to show you how this is built real quick. So to do that, I could right-click on this and I can delete. It does the same thing if you pick NA from the list here. Let's build a map. So to do that, right-click, vertical adornment. Lots of tools here. Again, these are explained in detail in the NeoPrism application notes that we're happy to provide upon request. Let's select frequency domain analysis, and these are the curves for this page of EEG. And as we page forward, we can begin to see some peaks here, 15 to 16 hertz. There's the onset of that seizure, and that's a good representation of what's happening on the page. It's not using the range. Let's change that. Let's go to Properties, Data Ranges, and we'll pick Ranges. It could be visible or all. Select OK, and we can see this tightening up a bit because now we're just marking that selected piece here, and we can see the peak right around 15, 16 hertz there. Okay, let's add some bands to this. Go to Properties, and we can do them by hand. So I can do bin analysis here, and I can create a new bin and set my lower limit of 1, my upper limit of 4, and add that bin, and then continue to go through that. Say new, I'm going to set my next one 48. So you can do it by hand and set your own bins. You can do alpha 1, alpha 2, beta 1, beta 2, however you want to do it. Or you can have them saved and load them from a file down here in the bottom right, load from file. This is already going to this folder. This is a hidden folder in Windows 7 and in Windows 10. This is where Windows 7 and 10 like to store settings for programs. If it doesn't show up, then you just type in program data and hit enter. Let's go ahead and put the whole path in here. There we go. Program data, persist, and here we are. So FDA, frequency domain analysis, FDA bins.xml. Let's see what happens when we open that up. The bins are already there. So let's click OK, and then we'll see a bunch of lines show up on this. So there's our delta, theta, alpha, beta ranges, and there are frequencies plotted along the bottom. Okay, next thing. Let's go ahead and add a table to this so we can see the numbers. So when I do FDA table, I get delta, theta, alpha, and you see there's two here. There's average and sum. Well, let's just pick one. So let's go to properties for this. Average amplitude, of course, each one of these bins with the default FFT parameters, it just happens to be about 1 hertz per bin. 1 hertz per bin, actually. So we're calculating 0 to 1, 1 to 2, 2 to 3, and so on, up through, up to half the sampling rate. And in the bins, we could take the amplitude of each one of those measurements. What's the EEG amplitude, for instance, from 8 to 9 hertz, measure that in microvolts, 9 to 10 hertz, measure that in microvolts. Add them all up, divided by the number of 1 hertz bins, and you get the average. Or you can take the sum, which is just taking all of those and adding them together, so you get the integrated amplitude or the area of the curve for that. So let's go ahead and pick average. You can pick either one. Since the bins tend to get larger as you go higher in frequency here, or these bands, of course, delta tends to contribute more to the EEG in a lot of places in the EEG. So average amplitude is going to be more in line with what you'd see and say, oh, well, I believe it's this amplitude. Sum is going to, of course, be higher than that because it's summing the values. You can pick any one. Of course, you can pick peak and mean frequencies to display in that table as well, but that's what that's doing. All right, now let's take this and turn it into a topograph. So right-click, insert topograph, and it's laying it over top of these, and we can make this a little bit different layout by just moving our mouse till it becomes a two-headed arrow, and then we can move things left or right and position them as we like. Now for the map, let's change the map a little bit. This is using what we call an RGB cube color palette, and so the colors get brighter as you go higher up. Not a bad one. You could pick, for voltage plotting, the blue, white, red makes sense because then you have blue and showing typically layout. increasingly positive red showing increasingly negative. It's a 200 scale. You could do that, but since there's not positivity or negativity in this display, it's just showing increasing amplitude. So it's not like a voltage map. And so picking something that will show increasing amplitude this way is helpful because the darker colors are lower amplitude, and then you get to the brighter colors, there's more amplitude. So voltage and frequency mapping, voltage, we're looking at something different, positivity and negativity. Here, it's just amplitude. So by frequency. Topograph, we can show a template, which is just going to show little cross hatches where the electrodes are, and you can show the electrode names and so forth, even plot their values in there. And there's lines on this map. If you don't want those, we can get rid of them, smooth it out. And let's go ahead and click OK. And of course, it just makes those lines disappear. So there's different options for the maps. Let's go ahead and apply this map as we step through. And again, we'll see that color change happening and then making its way down from beta to alpha, down to theta as that seizure evolves. And again, since we're using the sum, we see that the contribution of the high faster frequencies is still showing up in this. And we can change that. Let's see what happens if we modify the parameters for this. And I'll wait till it's finished paging and updating because I clicked it a bunch of times. So you actually get a little bit of animation going inadvertently. Let's go to properties, and I'm going to pick the average amplitude, and we'll see how the maps look different. Go back to the onset of the seizure. And we'll just, again, arrow through that. There's the onset. And as we go further through that, you can see the beta display drops out a little more quickly. So the average is probably going to show a little bit, the numbers are going to agree more with what you're looking at on the screen, just as visual estimation. So, but those are the two options you have for representing those values. That is a quick tour through the frequency mapping. Hope it's helpful. I'm always happy to connect to answer any questions or to step through any examples and to configure this on your system. And once it is configured, then we can go ahead and save this as an adornment montage. So I don't have to reproduce this every single time. I'm just going to call this new. And now I can just pick it from the list. So there's that. There's my default one, which is using the current page. And since I've already have a range applied here, I can pick the new one, and that's going to apply the range. So you don't have to rebuild them every time. Thank you for watching. Any questions? Happy to answer them. Have a great day.